Chapter 6.5 is on tables and graphs, and Dr. Maroli has decided, because that's somewhat separate from our discussion of graphing linear equations and some of the information we're going to use in Chapter 7, we're skipping 6.5, and so our last section of Chapter 6 is 6.4. In 6.4, what we're going to discuss is the slope of a graph, or a slope of a linear equation. And the reason we're doing that is later on we're going to use a formula which is y equals mx plus b. We'll use that for figuring out a variety of things. We might use it to figure out the slope, the x value, the y value, or what b is. We'll get to that in Chapter 7. But the key to this happens to be this m right here. And we have a specific formula for figuring out what m is. That formula happens to be m is equal to y2 minus y1 over x2 minus x1. So let's take a look at problem number 2. We have the points 4, 9 and 8, 17. What I sometimes like to do to make sure I've got this correct is I'll write my points 4, 9, and underneath it, and this is point 1, so I'll call this x1, and I'll call this y1. And then for my other point, 8, 17, I will call this x2, and this is y2. So, if we use that slope formula, we would put in m equals y2 minus y1 over x2 minus x1. And now when we go back up, we pick out the correct numbers to put into each place. y2 happens to be right over here. That's y2. So we put in 17 minus, and y1 happens to be right there. So we put in minus 9 over, and now x2 happens to be this value right here. So we're going to the second set of numbers first in order to plug this in correctly. 8 minus, and then of course x1 is right here, and that's 4. Now what we get is m equals 17 minus 9 happens to be 8. 8 minus 4 happens to be 4, and so m is equal to 2. Now what we need to show you is, let's assume that some people decide they're going to label these differently. Will we get the same slope? We got right here m equals 2. Let's go ahead and plug these in, but let's do it in a different order. I'm going to go rewrite this again. I've got that one answer, but I'm going to erase these right here. And now what I'm going to do is, let's say that when I plug these in, for some reason somebody decided that for 4, 9, they're going to call this x2, y2. And for 8, 17, they're going to call this x1, y1. So let's take a look now. Using our formula, m equals y2 minus y1 over x2 minus x1. In this particular case, the y2 now is right here. And so what we plug in is 9, and the y1 is over here, minus 17. over, and in this particular case, the x2 is here. So we put 4 minus the other x, or the x1, which is right here, and that's 8. Now m equals 9 negative 17 gives us a negative 8, and 4 and negative 8 gives us a negative 4. But now, if we divide negative 8 by negative 4, we get 2. The reason I did it that way is just to show you that if you pair the numbers and you want to use those first pair as x2 and y2 instead of x1 and y1, you're more than welcome to do that. You should get the same answer no matter which way you put the order. But just be sure that the second number in each pair is the y, and the first number is the x. So now that we've done that, let's go ahead and take a look at problem number 6. So I'm going to erase some of this because we're spilling over. And now from this point on, the assumption is you're going to be able to spot. I tend to use the second pair as x2 and y2. So I'll just put a little note over here. That's going to be x2, y2. This will be x1, y1. So in this particular case, m equals y2 minus y1 over x2 minus x1. M is equal to, I've got a negative 4 there, minus, and y1 is a negative 5, over x2 is 1, minus, and x1 is a negative 2. Notice I put those in parentheses because I'm subtracting negative numbers both in the numerator and the denominator. What this then becomes is negative 4 plus 5 over 1 plus 2. And when I combine those terms, negative 4 and a positive 5 gives me 1 over 3. And 1/3 happens to be the answer for number 6. Let's take a look at number 12. In number 12, again, this will be x1, y1, and x2, y2. In number 12 now, what we'll do, m equals y2 minus y1 over x2 minus x1. M is equal to, y2 is 8 minus, and y1 is 8. And then x2 is 6 minus a negative 2. M then equals 0 over 6 plus 2, or m equals 0 over 8. M equals 0. What that means is that turns out to be a flat line. When m is 0, what you have is a horizontal line. That's the reason I showed you number 12. I want to take a look at one more set of paired numbers, and that happens to be number 14. In number 14, the combination happens to be negative 5, comma, negative 3, and negative 5, comma, 2. So, m equals y2 minus y1 over x2 minus x1. M then equals, and our y2 happens to be this time 2, minus our y1 is a negative 3, over y2 being, or x2 being minus 5, minus a negative 5. When we combine terms, or remove the parentheses I should say, we'll get 2 plus 3 over minus 5 plus 5. In this particular case, we get m equals 5 over 0, and that's considered undefined. in this particular case, an undefined line would be one that's straight up and down, it's straight vertical. So in number 12, we had 0, which would be a horizontal line. In 14, we had one that's undefined, which would be a vertical line. Now what we want to do is we want to move up on the page and take a look at a couple other features. I've got 30 written there, but before we do that, let's look at number 20. In number 20, we have a pair of numbers, but, a pair of points. We don't have a line yet. And what we have to do is we have to look at that graph and say, what are those 2 points? The one that is above the x-axis and to the right of the y-axis, if we look at that, we count over 2 to the right and up 4. So that first point happens to be 2, 4. Both of those being positive, you'll notice that's in the first quadrant. If you'll notice, the second point is in the fourth quadrant. The x value happens to be positive, and you have to go out 1, 2, 3, 4, 5, 6 places. You go out 6, so that x is 6, but now you need to go down below the x-axis 3, and that becomes -3. Reading the points is the most important thing. Now in solving it, you get m equals y2 minus y1 over x2 minus x1. And m equals, now our y2 in this case is -3 minus y1, which is 4, over x2, which is 6, minus x1, which is 2. M then equals -7 over 4. And typically they just write it as -7 over 4 as an improper fraction. You could put -1 3/4 if you want to. The last one we want to look at is number 30. So we're going to erase what we did here. In fact, this was problem number 20, the one we just did. Now we're going to go ahead and erase and do problem number 30. In problem number 30, we actually have a graph of a linear equation. I've tried to replicate it there. Unfortunately, my little blue line happens to have a glitch in it, but it should look similar to the one you have. When you look at that, where you have to find is, where does that blue line cross an intersection right at a point? Now, in this particular case, there's quite a few. I've picked 2 of them. The first one I picked is in the second quadrant, sitting up here, right up there. And then the other point I picked was in the fourth quadrant, and it sits right over here, right there. When I looked at those, the coordinates that I got for that first point were -6, 5. So it's in the negative column on the x-axis, but up, the positive, in the y-axis. The second point was a +3, but a -1. You may want to check me on that. Once I've gotten those 2 points where that linear equation crosses, now what I need to do is just go back to my formula. M equals y2 minus y1 over x2 minus x1. But we haven't decided which is which. So what I'm going to do is I'm going to say that my first point that I picked will be my x1, y1. And my second point that I picked will be my x2, y2. Looking at that then, my y2 happens to be -1 minus my y1, which happens to be 5. In the denominator, my x2 happens to be 3, and my x1 happens to be -6. All right, make sure I plug that in properly. In the numerator, 1 negative and 5 more negatives makes -6. In my denominator, what I have is 3 plus 6. So what I have is m equals -6 over 9. And that can be reduced down to -2/3. So you should be able to plot points when you're given 2 points, when you've gotten 2 points on a graph like with number 20, or when you actually have a linear equation like we did with number 30.